Let us recall how to convert fractions into decimals. We know if our fractions have denominators 10, 100, 1000 and so on, then we can easily convert them into decimals. Just like here the decimal version is 0.7, here it is 0.04, and if the fraction is 44 over 1000, then the decimal representation is gonna be 0.044. So the fractions whose denominators are of the form 10 raised to power n, those can be easily converted into decimals. Here the denominator is 10 raised to power 1. Here the denominator is 10 raised to power 2. Okay. So such fractions can be easily converted into decimals. Now the fractions whose denominators are not of the form 10 raised to power n, means they are neither 10 nor 100 nor 1000 and so on, then we have two way outs to convert them into decimal. The first way out is to just divide numerator by the denominator. Okay, this works for all of the fractions. And one more simpler way out is just to convert the fraction into an equivalent fractions whose denominators are of the form 10 raised to power n. But all fractions cannot be converted into such forms. Okay, let's see here. Here, to convert this into decimal, either we have to divide 3 by 5, or we have the second way out also, to convert this fraction into an equivalent fraction whose denominator is either 10, 100 or 1000. So can this denominator be converted into 10 raised to power n, means either 10, 100 or 1000? Yes. 5 can be easily converted into 10 by multiplying with 2. So the equivalent fraction here became actually 6 over 10. 3/5 is equals to 6 over 10. So the decimal representation is 0.6. Here also the decimal denominator can be converted into 10 by multiplying with 5. So the decimal representation for this number will become 0.5, as the equivalent fraction is 5/10. Can we convert this into a decimal by this method? That can be checked by prime factorizing it. See, I'm telling you multiple concepts here. 5 and 2, by looking at the numbers, we can easily find out whether they can be converted into 10 or 100 or 1000. At times we are not able to find. I'm just telling you how to do that. See, can 8 be converted into 10 raised to power n? Yes, it can be converted. How did I get to know? So whenever you have to check whether a particular number can be converted into 10, 100 or 1000, just prime factorize that number. I've already told you the importance of prime factorization last year. Okay, so here the prime factorization for 8 is this. Can 8 be converted into 10 raised to power n? Yes, easily, because each of these two can be converted into 10 by multiplying with 5. So by multiplying 8 with 5 into 5 into 5, that means 125. No? So we multiplied the denominator by 125 and we are multiplying the numerator also by 125, and we actually got a fraction whose denominator is of the form 10 raised to power 3. Now 1 10, second 10, third 10. So this 125 into 3 is 375. And now the decimal version can be easily written as like this. Okay. Now here, can we convert this into decimal by this method? That can be checked by prime factorizing the denominator. So here the denominator is this. So 5 into 3. Can we convert them into tens? So 5 can be converted into 10, but 3 cannot be. So this fraction cannot be converted into decimals by this method. So what's the option left? The first option, dividing the numerator by the denominator. Let's divide that. I have opened a calculator here. So here this is 4, this is 15. The calculator is something different. So x and y, and the fraction is x upon y. Okay, so if we divide 4 by 15, so plus minus multiplication, this one is division, so the answer is this. Okay, What type of answer is this? See, you must have seen in junior classes when you divide a number by the other, the decimal doesn't terminate, it keeps on recurring. It happens, no? And here, even here, it's not terminating. Here it has been written 20, that's why it's after decimal it is showing us 20 places. If I make it 100, okay, and then redo it, so it will give me an answer till 100 places. See, 6 is still recurring, it will keep on recurring. Okay, so how to write such an answer in mathematics? So there is a way out. So one more purpose for this video was this, how to get you people acquainted with such a writing pattern. So here the answer is this, and how to write it in mathematics. No, not even this. No, this is actually showing me rounded off answer. Just write 6 once and put a bar over 6, a bar like this. Okay, not over 2, only over 6. Whatever is repeating, over that we have to put the bar. Okay, so I'll give you some fractions to convert into decimals. You have to choose the repeating digit, repeating string, and put a bar over it. Let's discuss few more examples here. Let's take it as 5 over let's take it as 14. 5 over 14. Okay, and let's check the decimal expansion for this. Here, if you see the result carefully, it's 35714,285. Okay, so what's here also you can see some repetition. Okay, if this is not ending, if I further do it by till 100 places, you can see some repetition. So you just have to identify your repeating string. So it's 571. See, 3 is not repeating anyway. So it's 571428. No, this is your repeating string. You can see 571428. 571428. Okay, so what's the answer? So answer here, this. And what was the question? I forgot. I suppose 5 over 14. No, let's type it, 5 over 14. So the decimal version is this, but is this the answer? No, this is not the answer. Okay, there should be a bar over 571428. Okay, so this is a way to write the decimal form of some of the fractions. So if I summarize, you learned 2 new things in this video. The first one, how to find out whether the denominator of a fraction is convertible into 10 raised to power n form or not. And the answer is, we have to prime factorize the denominator. Okay, so if it can be converted into 10, means the denominator should have 2 and 5 only, because 2 can be converted into 10 and 5 can be converted into 10. Rest cannot be. So if the denominator is 15, so 5 into 3, 5 can be convertible but 3 not. That's why 15 cannot be convertible. Got it? So one thing, whose denominator can be converted into 10 raised to power n form. The second thing you learned, how to represent the repeating decimals in compact form, means the bar notation. Okay, that's all for this video. Thank you.